Today we're going to graph some rational functions with oblique asymptotes. So let's start off with the rational function x squared minus x over x plus 1. So we know that the domain will be all reals except for -1. We have a vertical asymptote where the denominator is equal to 0, and that's at x equals -1. So I'm going to draw in my vertical asymptote at x equals -1. We have no horizontal asymptote. But we do have an oblique asymptote. Because the degree of the numerator is 1 more than the degree of the denominator. And we're going to find that by dividing. So x plus 1 into x squared minus x. And I'll add my plus 0. So x squared divided by x is x. We get x squared plus x. When we subtract, bring down, -2x divided by x is -2. We have a remainder of 2, but we're not going to worry about that. Our oblique asymptote is at y equals x minus 2. So when we sketch that, we know that our y-intercept is at -2, and we've got a slope of 1. So up 1 over 1. So our oblique asymptote looks like that. Now we find our intercepts. We find the x-intercept by setting y equal to 0. So x squared minus x over x plus 1 equals 0. That's when x squared minus x equals 0. We can factor out an x. And our x-intercepts are happening at 0 and 1. Our y-intercept is going to happen when x is equal to 0. And that's at y equals 0, which we already have because we've got x equals 0. And last, if we look at our symmetry, we've got -x squared minus -x over -x plus 1. Now this is not equal to f of x, nor is it equal to -f of x. So this function is not even and also not odd. So you'll see here that we still have, using our asymptotes, these sections, 4 sections. So we've got this large section here, this little section here, and another large section. So we have to decide which 2 our graph is going to appear in. So we know that since we have some intercepts here, that our graph has to go something like that. So below the x-axis, and then asymptotic to our oblique and vertical asymptotes. Now the next part cannot go here because then we wouldn't pass the vertical line test. We could potentially have part of our function here, except that we'd have to pass through the x-axis again, and we only found 2 intercepts, which means that the other part of our function must be down here. So make sure you have labels. It's x and y will indicate a scale on both axes. And that is it.